What is it about quantum theory that so troubled Einstein that he would spend nearly a quarter of his life trying to find a replacement for it? The answer is perhaps a bit simpler than we might suspect. Einstein was a realist and believed in an objective universe that exists outside of our subjective observations of it. What so bothered Einstein about quantum theory, even though he contributed to it with his photoelectric effect and Browninian motion papers and appreciated its many strengths, was that it was inherently probabilistic, and that at its philosophic and methodological core was an uncertainty principle which pointed to the variability of human measurement. As John Wheeler, the eminent physicist at Cornell and Princeton and the University of Texas at Austin, later stated, "There is no phenomena unless it is an observed phenomena." This was intolerable to Einstein, since, as he suggested to his eventual biographer and physics colleague, Abraham Pace, the moon really does exist, even when I don't look at it. Einstein's objections to quantum theory took two major turns. First, almost from the outset, Einstein attempted to show how the new quantum mechanics, as defined by Heisenberg and Bohr, was mistaken. Later, Einstein accepted to some measure the correctness of quantum theory, but tried to point out how it was an incomplete theory, and most likely a bridge theory to something much more comprehensive and complete. One of the sticking points for Einstein was the breakdown of individual causality inherent in quantum theory, where a measuring device a priori determines the outcome of a quantum state. As the science magazine Seed explains it, Schrödinger and Heisenberg independently uncovered dual descriptions of particles and atoms. Later, the theories proved equivalent. Then, in 1926, Max Born discovered why no one had found a physical interpretation for Schrödinger's wave function. They are not physical waves at all. Rather, the wave function includes all the possible states of a system. Superposition is one of the defining qualities of quantum mechanics and implies that individual events cannot be predicted. Only the probability of an experimental outcome can be derived. The fact that quantum theory involves a connection between a measuring device and how we can ascertain reality was, for Einstein, fundamentally problematic. In a now famous letter to Max Born dated March 3, 1947, Einstein outlines why. "I cannot make a case for my attitude in physics which you would consider at all reasonable. I admit, of course, that there is a considerable amount of validity in the statistical approach which you were the first to recognize clearly as necessary given the framework of the existing formalism. I cannot seriously believe in it because the theory cannot be reconciled with the idea that physics should represent a reality in time and space free from spooky actions at a distance. I am, however, not yet firmly convinced that it can really be achieved with a continuous field theory, although I have discovered a possible way of doing this which so far seems quite reasonable. The calculation difficulties are so great that I will be biting the dust long before I myself can be fully convinced of it. But I am quite convinced that someone will eventually come up with a theory whose objects, connected by laws, are not probabilities but considered facts, as used to be taken for granted until quite recently. I cannot, however, base this conviction on logical reasons, but can only produce my little finger as a witness. That is, I offer no authority which would be able to command any kind of respect outside of my own hand." What reality was Einstein presupposing here? An external world free from human measurement, a world which exists truly and clearly apart from human subjectivity? But as Einstein rightly surmised, this objective world collapses with Heisenberg's uncertainty principle, since external reality at its most fundamental constituency is absolutely unknowable, except through a measuring device, which in and of itself alters what is known. In other words, quantum mechanics is a statement about reality itself, and what it is saying is that there is no world out there apart from our observations of it. Our observations, in other words, are part and parcel of what we observe. The dualistic idea of a world apart from ourselves is a fiction. For Einstein, this was the very antithesis of science in general, and physics in particular. The whole scientific enterprise was predicated on the notion of an external world, which was independent of the machinations of the subjective participants that arose within it. But the real culprit here in Einstein's mind is the introduction of probability and statistics as a final pathway for understanding the underlying laws of subatomic materials. While Einstein readily concedes the powerful utility of Born's statistical understanding of wave matrices, his little finger tells him that quantum mechanics is merely a prelude to a greater and more unified theory, which will eventually transcend probability functions and yield a straightforward and causal and objective explanation of how and why matter behaves the way it does.